the material. So we had this on our list of topics today, general information. We've gone through course material overview and introductions to the teaching team. But it's MIT, so we need to start with the quiz. The quiz is, can you tell me who these people are? So who is this? It is me. This is my college yearbook picture. So one day you will have one of these. Who is this? It's not me. People say that, but thank you. It is Lisa Kudrow. So who knows who Lisa Kudrow is? Friends, yes. So Lisa Kudrow and I were classmates. We were in the same year. So you can look at who's next to you and figure out, who in your row is going to be that famous person that one day you can say, yes, I was classmates with them. So Lisa and I were classmates. What do you think Lisa went to college to study? I heard the correct answer out there. It was, in fact, biology. What do you think I went to college to study? Yes, some people have watched my open courseware and know these things. Yes, theater, drama, biopsychology, that's kind of like course 9. That's what I was interested in. What do you think Lisa majored in? Biology? Or drama? It was biology. What do you think I majored in? It was chemistry. And of course, we all know that Lisa is an actress and I am a chemistry professor. So I like to start every class with this because I think it says something very important. I did not like chemistry in high school. I was in chorus, I would schedule every one of my music lessons during the chemistry class. I did everything to avoid having to attend chemistry in high school. And then I went to college, and they said, you have to take chemistry if you're thinking of a biopsychology major. And I was like, I have taken chemistry, I'm quite convinced chemistry is not relevant to biology in any way. I was told I was wrong, I was sure I was right. I took chemistry and realized that chemistry can be very different in different circumstances, and that everybody can find their appreciation for chemistry at a different time in their lives. Some of you right now already like chemistry, but a lot of you probably have not found your love for chemistry yet. Some of you may find that love for chemistry during this semester. I'm hoping it'll be a large fraction of you. Some of you may not find your love for chemistry until next year, or senior year at MIT, or even in graduate school, or even when you have a job later on. Sometimes when I'm traveling around, and as a professor, I travel the world and give talks, and I'm chatting with someone in an airplane or on a bus or something, and they say, what do you do? And then I say, I teach chemistry, and I always kind of watch the reaction to that. And some of them are like, oh, chemistry, and other people say, boy, I'm an engineer now, and I have to work with chemists all the time, and I really wish I had paid more attention in chemistry class because we need to work together, and I need to understand more what they're doing. So some people do not find their love or their appreciation for chemistry till they have a career later in life. So I'm not sure when it's going to be for all of you, but if you have not found it yet, I am hoping to find a connection, your connection to chemistry. What about chemistry relates to what you want to do in the future? And one reason that I did not appreciate chemistry in high school is I didn't really understand who chemists were, and I didn't really understand what chemistry was, what people used chemistry for. And part of the reason, I think, were these pictures that are often shown in courses, in intro courses for chemistry and in your intro textbooks. That's partly why I think $8 is a good price to spend on these chemistry textbooks. These were great chemists, but they're all dead. And that really gives the message that chemistry is not a living discipline. Chemistry was a thing that people used to do, and it was exciting at that time, but then when they got rid of their powdered wigs, they moved on to other fields. So I'm going to be showing you some different pictures in this class. I'm going to be showing you these pictures. Some of the old pictures will be there too, but every time I show you a dead white guy, I want to show you someone who's alive. So these are living chemists, people who are using chemistry every day of their lives. And I'm going to be showing short videos of these people telling you how they're using chemistry and what chemistry is being used for today. So you'll be hearing, and this is a series I call In Their Own Words. Another thing that I didn't appreciate about chemistry was in the lab course I had, we had a strong base and a weak acid, and we would drop, 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 until it turned pink, and then we could calculate the molecular weight of an unknown weak acid. And I asked myself, is this like a real pressing problem? There are like a lot of weak acids out there somewhere that if only we knew the molecular weight, the problems of the world would be solved. But it turns out that this is kind of a good intro lab, but it's in fact not what chemists do every day. We will learn about titrations because we need to know pKa, because pKa is important, but we don't have a lab and we're not going to be doing that experiment. So what is chemistry research? Chemistry research is all of these following things. So creating quantum dots to be used in surgery. How do you know if the doctor's got the right amount of a tumor? You don't want to take more flesh than you need, but you don't want to miss some of the cancer. So you want to image exactly where that cancer is. Chemistry is designing sensors to find explosives in war zones. This is a really important problem right now. Biofuels, energy, alternative energy. That's what chemistry is, using basic principles to figure out how to design better biofuels. Or making new pharmaceuticals. We haven't really produced new antibiotics in a long time in this country. And a lot of things that we thought used to be treatable conditions now are no longer so treatable because we don't have new antibiotics and the bugs are becoming resistant to the old ones. This is what chemistry research is today. This is what you're going to be using chemical principles for. So what chemical principles are you going to be learning that will help you solve these real-world problems? So we need to learn about matter, and we need to know how matter reacts. So in the first half of the course, we're going to start with atomic theory. There is going to be a little bit of history involved in that, talking about the discovery of the nucleus, electrons, protons. And so we're going to have a little bit of history and some cool demos. We're going to move on to the periodic table. That's the chemist's toolbox. Those are the elements that we can combine to make things. And when we combine them to make things, they need to bond. So we're going to talk about bonding. And they're going to form molecules. And we need to think about the structures of those molecules because the structures dictate the properties of those molecules, of that matter. And then molecules can react. So we're going to talk about how they react. And whether a reaction is going to go is about thermodynamics. Is it going to be spontaneous? But then we also need to know if it's fast or if it's slow. That's kinetics. So we're going to cover both of those things. Chemical equilibrium. You can have a reaction that goes one way and is going in the reverse direction at the same time. And there'll be an equilibrium constant associated with that reaction, but sometimes you really want to go more in the forward direction to make the thing you want to make. So you need to think about how the reaction quotient Q is related to the equilibrium constant K. And if you're the Green Lantern, equilibrium constants are meaningless. You have the Green Lantern ring, and you can push that equilibrium any direction that you want. If you're the Green Lantern, Q is always greater than K. But if you're a student of chemistry, you actually can become a superhero by learning about those chemical principles, and then you can drive Q to be greater than K as well. So I want to teach you how to be a superhero. I also am going to teach you about solubility and acid-base and oxidation-reduction reactions, because those are really the fundamental types of reactions that occur in biology, in materials, in everything. And a little unit on transition metals, that middle part of the periodic table where you have iron and cobalt and copper and nickel and all those amazing elements that really allow you to do the most challenging chemical reactions. Those are especially fun. And if you want to have the power of chemistry, you got to know about the transition metals. All right, so without chemistry, you wouldn't be alive. Your body are a series of chemical reactions. You wouldn't be wearing the clothes that you're wearing. Pretty much a chemist figured out the material that you're wearing and or how to process it. And I think really importantly, you couldn't spell MIT without chemistry. We have the M from physics, the I from math, and we have the T from chemistry. So if you want to spell MIT, you got to learn about the ideal gas law. And you wouldn't have the paper that you might be currently writing on without chemistry. So chemistry, you really should study chemistry because the major challenges of our time require chemistry knowledge to fix them. Treating human disease requires an understanding of chemistry. Solving the energy problem requires an understanding of chemistry. And I believe people will come up with alternative energy. I'm just less convinced that they're not going to destroy the environment while they do it. So I really think we need people thinking about solving the energy problem who care about the environment and can use chemistry to think about how we can protect the environment. So why do I care so much about this? And that's because yesterday morning I walked my daughter to her first day of first grade. She's 6 years old, she's starting school, and I need people to know chemistry to make the world a better place for her. So what I can do as a mother who's a chemist is find the smartest people I can find, which I've done, and then teach them the chemical principles they know to make the world a better place for my daughter. So what I'm hoping that you will do, here are my course objectives. I said I'd get back to these. I want you to have a working knowledge of chemistry that you can take advanced courses. Starting pretty simple, that's what I want. I also want you to know enough chemistry so you can do a UROP in a chemistry lab. And we'll talk more about the undergraduate research program throughout the course. I would like you to employ chemistry principles in a lab that's not a chemistry lab in your UROP. I want you to appreciate how chemistry is used to solve real-world problems, to make informed decisions about your health, about the environment and energy and science policy. And I want you to be able to advance science and engineering through the application of chemistry principles, because I want you to make the world a better place for my daughter. And that's why I want you all to have superior knowledge, because my daughter needs more than adequate knowledge to have a better world. She needs superior knowledge. So that's my goal for all of you, to teach you these things. You don't all have to become chemists. In fact, it's fantastic if you take the knowledge of chemistry and bring it to other disciplines, because we're going to need all the disciplines coming together with that solid knowledge to be able to make this world a better place. I'll say that there are many 511-1 superstars in this class in the past who came in, like Sarah, who hated chemistry and became a chem major and ended up getting a PhD in chemical biology. All these folks have gone on using chemistry, not all as chemists, in biological engineering, full ride scholarship to medical school, PhD in biology, running a local pharmaceutical company as an executive, doing biophysics out at UCSF. So all of these people learned the chemistry they needed to go on and do great things. And you can put your picture in there.